In this lesson, we're talking about prime numbers and prime factorization. Before we can talk about prime numbers and prime factorization, we first need to know what a factor is. A factor is a whole number that divides a non-zero whole number with remainder of 0. So that might sound like a really complicated definition. So let's take a look at an example. An instructor plans a dance routine for 20 dancers in rows. Each row has the same number of dancers. What are the arrangements the instructor can use? So what are all the ways we can multiply two whole numbers, to get to 20? Well, 1 times 20, 2 times 10, 3 times nothing, 4 times 5. So all I did was list out all the different arrangements the instructor can use. So this means they could have one row with 20 dancers in it. They could have 2 rows with 10 dancers in it, or 4 rows with 5 dancers in it, or 20 rows each with 1 dancer, 10 rows with 2, 5 rows with 4 each. Let's take a look at another example. A gift box must hold the same number of pairs in each row. You have 24 pairs. What arrangements can you use? So again, what whole numbers do I know that multiply together to equal 24? So before we listed the factors, another way you might see this done is using a factor rainbow. So we're going to write 1 and 24, because 1 times 24 is always going to give you 24. And you can draw a little rainbow connecting those two factors. We also have 2 and 12. 3 and 8, and then 4 and 6. And that is what we call a factor rainbow. And as you can see, we count up until we reach the other numbers. So like 1, 2, 3, 4, 5 isn't a factor. Now I'm at 6. There's no other number that multiplies between 4 and 6 to get me 24. Now that we've learned what factors are, we can talk about composite and prime numbers. So a composite number is a whole number greater than 1 with more than 2 factors. So if I flip back here, 20 and 24 are both composite numbers. They have more than one set of factors that multiply together to give you that number. So 48 is another example of a composite number. 14 is a composite number. All the even numbers really are composite numbers, and most of the odd numbers as well. A prime number is a whole number with exactly 2 factors, 1 and the number itself. So now we have 2 examples. Is 51 prime or composite? So this is where it might be helpful to look at those divisibility rules. So 51 is not divisible by 2. The last digit isn't even or it's 0. Is it divisible by 3? Well, if the sum of the digits is divisible by 3. So we have 5 plus 1 equals 6. 6 is divisible by 3, so that means that 51 is divisible by 3. Because it's divisible by 3, that makes this number composite. Now we have, is 53 prime or composite? So let's check and see if it's divisible by 2. Is the last digit even or 0? Well, 3 is not even nor 0. Is it divisible by 3? If the sum of the digits is divisible by 3, so 5 plus 3 gives you 8. 8 is not divisible by 3, so that doesn't work. If the last 2 digits are divisible by 4, so 53, well, there's no multiplication fact that I know of with whole numbers that multiply together to give you 53, including a 4. If the last digit is 0 or 5, 3 is not 0 or 5. If the number is both divisible by 2 and 3, well, that's a no-go on 53 again. If the last 3 digits are divisible by 8, nope. If the sum of the digits is divisible by 9, 8 is not divisible by 9. And then 10 if the last digit is 0. 3 is not 0. So this number is prime. We could not list out all of the factors of 53 besides 1 times 53. That's what makes that number prime. If we look back at this example, is 51 prime or composite? Well, I know that 1 times 51 is is a factor pair. 2 doesn't work, but we know 3. And let's find out what number goes into 3 goes into 51 how many times? 17 times. So there's our factor rainbow. There are no other numbers that 51 is divisible by. But if you look, I have 2 sets of factors. That makes 51 composite because I have 1 in itself and then some other pair of numbers that multiply together to get me 51. That's what makes a number a composite. The last part of this chapter is called prime factorization. Prime factorization is writing a composite number as a product of prime numbers, and composite numbers only have one prime factorization. So in this example, we're going to write the prime factorization of 84. Now there are two ways really, that you can find the prime factorization. I'm going to show you how to use the factor tree. I've found that in my past experience teaching, most students like the factor tree. If the factor tree doesn't work for you, I'm happy to teach you another method, but for the sake of this video, we're just going to learn about the factor tree. So the factor tree looks like this. You put 84 at the top of your paper, at the top of wherever you're working, and then you make two little branches, and you list out 2 factors. Now, when you reach a prime factor, like the number 2, you're going to circle it. But we can continue breaking down 42. And I can continue breaking down 21. And now I've reached 2 more prime numbers. When I've circled all the numbers, there's no more composite numbers to break down. This is going to be your prime factorization. So 2 times 2 times 3 times 7 equals 84. This right here is the prime factorization of 84. You've now written 84 as a product of prime numbers only. There's one more thing I want to add on in this prime factorization. I've written 2 twice. So another way that you could write this is 2 to the second power times 3 times 7. That is the same thing. All right, now we have the prime factorization of 27. So again, I'm going to start with 27 at the top of wherever I'm working, and I'm going to break it down into factors that I know of. So I know that 3 times 9 gets me 27. 3 is a prime number, so I'm going to circle it. And I can break down 9 even more. So this right here is my prime factorization. So 3 times 3 times 3 is equal to 27. So again, that's my prime factorization, 3 times 3 times 3. And just like in the last example, we can rewrite this using exponents as 3 to the third. We're going to do one last example, finding the prime factorization of 48. So I'm going to break this down. And you might be thinking you could break it down into 12 and 4. Let's try that out too. And let's see if we get the same thing. I'm running out of space here, but I'll make it work. So now I'm doing it with 12 and 4 instead. Notice that I can break down both factors in this case. So in either case, I get 3 times 2 times 2 times 2 times 2, or 3 times 2 times 2 times 2 times 2. So I got the same thing. It did not matter which factors I broke 48 into. I get the same answer regardless. So my prime factorization of 48 is 2 times 2 times 2 times 2 times 3. Or using exponents, I could write that as 2 to the 4th times 3 equals 48. So again, in this lesson, we talked about finding factors, determining if a number is prime or composite, and then lastly, we talked about prime factorization. This was a pretty big section, and we're going to spend more than one day on it.